Greetings, my name is Dave Langer. This video is a free preview for my new online course, Our Programming Made Easy, Your Excel Skills Will Unlock Advanced Analytics. I have a firm belief that any professional, I don't care if you're in supply chain or in finance or IT or marketing, I'm talking about any professional that is motivated can learn R. And I created this course and these free preview videos to illustrate my belief that this is true. All you need is two things: Excel skills and the motivation to learn, and you can use R to unlock advanced analytics with your business data. Please enjoy the video. If you like what you see, you can either click on the link in the video description below the video to be taken to a course page with more information, or at any point in time you can just click up here and you can also get access to that same page. I hope you enjoyed the video, and until next time, stay healthy, and I wish you very happy data sleuthing. A very useful function for working with tables of data, for working with data frames of data in R, is the aggregate function. This function is going to be very intuitive to you as an Excel user. The aggregation of data is one of the most common tasks that you execute when you're analyzing data in Excel. This most commonly takes the form of using an Excel pivot table. So let's take the following example. You can see here that I have the iris dataset loaded up as a pivot table in Excel here, and I'm using the species column for the row labels, Setosa, Versicolor, and Virginica. And you can see here that I've ran a simple pivot where I'm executing the sum function on each of the numeric features: sepal length, sepal width, petal length, and petal width. So we can think of this as being the feature grouping. These are the groups. These are the buckets by which the pivot table then executes one of these aggregation functions. Things like sum and average and min and max. It's over the bucket of values that correspond to the sepal length data associated with the Setosa species. One way we can think of all of these columns of data in this pivot table is as the feature calculation by group. So we're taking the features: sepal length, sepal width, petal length, petal width. These are our features, and we're performing calculations on them, in this case the sum, and we're doing it by group. And in Excel, you could also do multi-level grouping. You could also have a secondary feature grouping, for example. So maybe there are subgroups A, B, and C. You could have Setosa A, B, and C, Versicolor A, B, and C, Virginica A, B, and C, so on and so forth. So really what we're talking about here is taking features, executing calculations on them by some sort of grouping. And it's often easiest to think about this conceptual idea in terminology where we're talking to Excel as an actor. So we could say, for example, hey Excel, can you sum up sepal length, sepal width, petal length, and petal width by species, please? And this is what you would get back as a result of that request from Excel. As a tool for working with data, it should come as no surprise that the aggregation of data is also one of the most common tasks in R. The R aggregate function allows you to perform pivot table-like calculations over groups of data. To use the aggregate function, you provide three pieces of information. One, a formula that specifies the features to use for calculations and for grouping. Two, the data frame that contains the specified features, the data that you want to pivot. And three, the calculation you wish to perform on the data. So you can see here, this is legit R code using the aggregate function. And I'm going to go ahead and unpack this piece by piece. So first up is the function call. It's just called aggregate, lowercase a. That's the function name in R. Now this part here is the formula. And let's walk through this a little bit. Think of the tilde here, this little squiggly, as being equivalent to the English word by. I would like to aggregate petal.width by species. So when you're using the aggregate function and you use the formula, everything to the right of the tilde, to the right of the squiggly line here, is your grouping variables. And they're typically either strings or, even better yet, they're factor variables, because factors are the explicit categorical or grouping data type in R. So this is where your groupings are listed. Over here are the pieces of data that you wish to do the calculations upon. So I'm saying, hey, R, please perform the aggregate function, and I would like to perform some calculations, some aggregate calculations on the petal.width feature grouped by species. Petal.width by species. Next up, we have the data frame. This is the object that holds all the data that we are aggregating, that we're pivoting. And then lastly, you have the calculation that you would like to run. And I'm telling R, I would like you to use the sum function, please. So sum up petal.width by species using the data in the iris_data data frame. And of course, this is the output. Now, just to really cement the idea here, here's the equivalent thing in Excel, in an Excel pivot table. Notice how the numbers are exactly the same. The output is basically exactly the same. Setosa 12.3, Versicolor 66.3, and Virginica 101.3, just like you see over here. One more instance of your Excel knowledge directly mapping to what you do in R. You create pivot tables in Excel all the time. You can do the same thing with the aggregate function over data frames. So next up, let's talk a little bit more about formulas. Formulas are very commonly used in R functions. A prime example of using formulas is with linear regression analyses. Specifying the linear regression equation is typically done in R using a formula syntax because they can be quite complicated, and formulas make this a lot easier. As you move on with R and you get more and more advanced in terms of the types of analyses that you do, you're going to see formulas crop up more and more often. For example, later on in the course, we're going to be working with the mighty ggplot2. ggplot2 uses a formula-like syntax for specifying how you can create certain types of visualizations. Formulas are extremely common. Good news is they're not all that difficult. In terms of the aggregate function, you can use formulas to specify multiple features for use in groupings and multiple features for use in calculations. So let me give you an example here with Excel. You can see here I've got species as my grouping variable, and I am actually calculating the sum on multiple features simultaneously, all 4 of the numeric features of the iris dataset. This is how I would do this. This is how I would accomplish this aggregation, this pivot in R using the aggregate function. Notice here that I'm using the cbind function, which we covered in a previous lecture. Cbind allows you to combine columns together. You invoke cbind, the cbind function here, and you provided a series of columns or vectors. And what will happen is cbind will then squish them all together essentially and create a table out of them. And so you can see here, if I want to use multiple numeric columns to create calculations with, just like I did up here in Excel, I need to use cbind, and I just put sepal length, sepal width, petal length, and petal width. Cbind them all together, and then tell the aggregate function, okay, I would like this combination of columns, this combination of numeric vectors, please. I want them aggregated by species, the grouping feature. And notice how it produces exactly the same output that we see here because I'm using the sum function here on the iris_data frame, and the pivoting is just like here in Excel, and the numbers match up exactly. This is how you can use the aggregate function on multiple numeric columns of data within a data frame simultaneously. You just cbind them all together. To finish off this lesson, I just wanted to go over a few more examples. So first up, notice that I have a pivot table in Excel where I've got the species column here as the grouping variable. And notice instead of summing up the numeric columns, I'm calculating the average by group for each one of these numeric features. And this is how I would do it with the aggregate function. Notice that the call to aggregate is exactly the same, except for the fact that I swap out the sum function for the mean function. In Excel, you use average. If you want the arithmetic mean or the average in R, you use the mean function. And notice how these values line up exactly with what we see in Excel. Next up, what's really common to do in an Excel pivot table is to do different types of calculations on the features. So what you can see here is I have a grouping by species, and I'm calculating the average of sepal length. I'm calculating the sum of sepal width, the count of petal length, and the max value of petal width. Different feature calculations here for each one of the numeric features. Now here's the kicker. This is extremely easily done in Excel. It's done all the time. However, the aggregate function in R only supports one calculation type at a time. You can pick either sum, or mean, or min, or max, or count. That's all you can do. You only one calculation at a time. You can have multiple columns, of course, upon which you do the calculation. That is totally okay. However, you can only have one calculation type with the aggregate function. That's not nearly as big of a problem as you might think. The mighty dplyr is the solution here. Later on in the course, we'll be using dplyr to massage our data, to pivot our data, to aggregate our data. dplyr supports all the kinds of features that you would expect based on your experience with Excel pivot tables. Anything basically you can do in an Excel pivot table, you can essentially do in dplyr. Here's our last example of this lesson on the aggregate function. And I've had to do a little bit of R magic here to get my example going. Specifically, I want to point this out right here. So what I've done is I've added a new feature, a new column, a new variable to the iris underscore data frame called sub.group. And what I've done with this particular feature, this new column, this new variable, is I crammed it full of A's and B's and C's. Specifically, what I'm doing here is I'm using the replicate function, the rep function, create a vector of strings, a vector of an A, a B, and a C. And I would like you to replicate this. I'd like you to repeat this 50 times, which will give me a total of 150 values, because we know there's 150 rows in the iris underscore data frame. I get some subgroups manufactured. And you can see up here in the data view, in the spreadsheet view, that I get A, B, C, A, B, C, A, B, C, so on and so forth, all the way down 150 rows. What I've done is I've essentially manufactured another subgroup, another factor, another category, because there's only one out of the box with the iris dataset, and I needed two for this particular example. Because what I wanted to demonstrate was how you can actually use multiple grouping features at the same time with the aggregate function. We saw already that you can use cbind to group a bunch of numeric columns together and have aggregate work over 4 columns all at once. But what we need to do if we want to work with multiple groups is we need to use the plus symbol here. This says, pivot all of these columns, please, by species and subgroup. And what you get in the output is exactly what you would expect. You can see Setosa, versicolor, and virginica for subgroup A, Setosa, versicolor, virginica for subgroup B, Setosa, versicolor, virginica for subgroup C. This works just like you would expect in a Excel pivot table where you have two groupings on the rows. You would have the primary group and then the subgroups, just like you see here. And the calculations, of course, are only made on the values associated with the combination of the top level group and the subgroup. So you can use the aggregate function to have multiple numeric features upon which you're doing the calculations. You can also have multiple grouping features if you would like, but once again, you only get one calculation function at a time. And to get around that, we're going to use the mighty dplyr later on in the course.